Even though it's only 7% of the size of a larger ARM device, the M7, we are getting almost comparable performance. The performance has improved from roughly 3x to 15x. Now, this would not be possible previously, but the real important aspect is that we are abstracting this acceleration from the software engineer.
Hello, we're at Embedded World 2025 and we're on the Codasip booth. And today we're going to be talking about how Codasip is helping engineers to create their own accelerators using their bounded customization. So we're here with Keith, who's going to tell you a little bit more.
Hello. The value that we are looking to address here is that a lot of engineers or companies need to address a particular domain, which means I have to reach a certain level of performance, but I also need to minimize cost. Now, what we've done here is we've taken a small core, our L110, and we're going to accelerate it to be faster than a much larger device. And this will enable new applications to occur. Now, if we take a look at this L110, even though it's only 7% of the size of a larger ARM device, the M7, we are getting almost comparable performance. Now, if I add some additional resources here, you can see that we've now improved the performance of our core. We've accelerated it to almost 3 times faster than the much larger core. But the real important aspect is that we are abstracting this acceleration from the software engineer. Software engineers love to use libraries. And what it enables you to do is add these custom instructions to accelerate the software, and the software does not need to change. We're using the CMSIS libraries because that is the libraries of the domain that we're trying to attract, or the domain that we are targeting, which is DSP applications, or neural networks for embedded space. Now, I've just added functionality, improved the performance, but the software has not changed. Now, I can add some additional circuitry resources, and now you can see that the performance has improved from roughly 3x to 15x. Now, this would not be possible previously. Now, our technology is enabling not just the processor companies or large corporations that have processing engineers as well as verification engineers to create their accelerators, but SoC companies, because the level of verification that they need is just a verification of the changes that they make to the core. Our base core remains 100% verified because we have put a boundary around the core that you cannot cross. So now companies that are system on chip that have no processor or verification experience can actually now add customization and improve and create new products. Now, as you can see, we've added some processor acceleration capability, but we provide multiple levels of acceleration because we do not know what type of application that the supplier can make or the SoC vendor will make. We also provide all the basic primitives so that it's easy for the SoC company to create their own accelerators. So we don't think we can, the world is so large out there, there's so many applications, we cannot think of all the different accelerators that people will need. So we want to make all the primitives available for their own applications so they can make their own accelerators.
What are some example applications that this could be used in?
I think a real good application would be like smart sensors. Now, previously we have, there are a lot of companies that make a sensor, and that sensor, it could be vibration, it could be temperature, or it could be audio, but there's a lot of sensors out there to enable automation, autonomous vehicles, and we need to make them smarter. By making them smarter, we can make things safer. For example, like in automotive, if we have a crash avoidance system, we want that sensor to know that a crash might occur sooner so that we can stop the car sooner to be safer. So a technology like this would enable smart sensors, because now a sensor company can actually bring in a processor that actually can be processing the data intelligently to provide a warning to the rest of the system quicker.
Yeah. So as an engineer, how would I get started?
Well, it's quite simple. We actually have a tool called Codasip Studio, and inside the tool, we would provide you the base IP. And so that base IP has some tutorials that would explain how to add your own custom instructions, as you would also get access to all the basic primitives. And we'll have all the training material to describe how to use them and how to create your own instructions.
So you can go to codasip.com to learn more.